Hello, welcome back for the second installment of L25 DSP amplifier, DIY amplifier build. I've got the major components wired up and functional. I've done some thinking about what kind of case I want to put it in, and I've done some shopping. You know, amplifiers usually come in a couple of different sorts, right? There's the typical ones from the 70s where they're kind of wide, not as deep. The heat sinks are either on the back or on the inside. Some of the newer ones are a little more open to having audio, car audio. You know, the amplifiers you would find in a car audio system where it's a metal box, really, right? And it's got heat sinks and fins down the side. You're seeing more and more of that style brought inside. I looked around, tried to find a case kit, right, that I could just put. It was hard to find one big enough that I could justify the expense. They were expensive. Now I'm a little more probably I'm not a very good carpenter, but I am definitely not a machinist. There's a YouTube guy, maybe I'll try to find the link, that built an aluminum case from scratch. I don't have that kind of skill level, but I can screw some wood together. So, probably not very fashionable for an electronic component, but my plan is to build a fair amount of this amplifier out of wood. Now, bear in mind that the whole sides, you know, the heat sinks are big, and they're going down the whole side. So, with that in mind, I kind of like to show you where my head is on how this thing could be sort of laid out. All right, so imagine these are the heat sinks. They are going to be about 14 inches long, and they're probably going to be thicker than this piece of wood. They're going to be, you know, over an inch thick, and probably about this tall. And the way I came up with the dimensions was based on how I had the amplifier laid out on my table. You saw that in the earlier video. So you know, if you remember the amplifier modules, imagine these are the amplifier modules. And then you had the power supply back here. And then you had the speaker protection circuit over here. And then I kind of have the DSP. The DSP would probably be here, you know. This is how it's kind of laid out right now on the table back there. So what I was thinking was, you know, usually you want to mount your amplifiers right in the middle of your heat sinks. So here's the heat sinks going down the side, right? Usually you want to mount your amplifier right in the middle, but in order to transfer the heat evenly, but I don't think I'm going to be able to do that. I think I'm going to have to offset them, this being the front. So big metal heat sinks, amplifiers. You'll have a front panel and a back panel. So if you kind of look at what you have structurally, and in order to make it rigid, you know, this is going to be able to flex this way. The front panel will be made out of a pretty thin material, probably like this, sort of a small plywood, 1/4 inch. I might be able to make the back panel out of something a little thicker. I've got a piece about this thick that's like a 3/8 plywood, but this is hard to find here in Georgia right now. I'm thinking that you know, once I get the top panel and the bottom panel made, that will add a lot of rigidity in this direction. But I am thinking about a center, like a center brace. So I guess imagine running through here and kind of separating the back section from the front section. There would be a middle brace to add rigidity. And I've got these L brackets. They're pretty big and stout. I will have to tap into the heatsink. Either this way or this way. I'm not sure which would be best. So I'll have L brackets here, and I'll have L brackets in the back, right? And L brackets in the back. These big L brackets. So that's 4 L brackets in the front. The front panel will probably just kind of be pulled up there. It's thin. It doesn't really add any structural integrity, really. And eventually, one day, I would really like to use like an 1/8 inch aluminum plate for the front panel. But I've looked around. I haven't really been able to find any. So with this, I think I'm pretty good shape because the L brackets will be strong. I'm going to go ahead and use a hard 3/4 inch piece of wood right through in this middle section. And in order to pass the wires, you know, there's going to be a lot of wires coming from the back to the front. I'll drill holes in this centerpiece, big holes that wires can go through, and then of course the holes for the L brackets here too. So I think that'll make a pretty solid framework out of wood, which I know is, you know, somewhat questionable, somewhat odd to, you know, build an amplifier out of wood. But that's the plan right now. I suppose if it doesn't work out, could probably replace some of these panels with metal, especially the bottom one, right? The bottom panel, the one that the circuit boards will be mounted to. Well, I mean, the amplifiers will be mounted to the heatsink. The heatsink forms a wall, right? And then if that is mounted to a metal plate on the bottom, well, so right now all we're doing is waiting for the heatsinks to arrive, and yeah, we'll start doing the build. Thanks for checking in on me. The heatsinks have arrived. It's about to get real interesting. Along with a bunch of other parts. A ESP32 with a small display to control the digital signal processor. And switches, rotary encoders, push buttons for the front panel. A tap set to tap all the things I gotta tap, including mostly, you know, the heatsink. Some little L brackets that are going to be pivotal in holding all this together. One side of that L bracket is tapped, so that'll come into play. Oh, and I had a programming breakthrough last night where I was able to finally figure out how to read the DSP parameters from the ESP32 over I2C command bus. So the next step on that is to learn how to write Shouldn't be that hard. I think I've skinned that cat. And yeah, I'll tell you what, it's not going to be long before we're going to be able to push these big old transistors here and see what they can do without having to worry about overheating them. It's too much. I have to make a shout out. Shout out to Michael Beanie for showing me how to tap a hole. Set to a half turn and back it up a half turn, and you can feel it. You can feel it get tight. And then when you back it out, right, and then go again, it's not as tight. This is a really small tap. You get it. If you were to get too much pressure going, you might break the tap. I think I'm through now. On the other side, I'm probably only cutting a little bit of a thread into the fin. Yeah, I think I'm through. When I first received this amplifier, I thought it was a bit odd that the angle iron, they call it, it's got grooves in it. It's got, I mean, they're not real pronounced. Yeah, that's pretty smooth. Well, there's definitely grooves there. It's got grooves in it, which I thought was a bit odd. I would think the interfacing surface should probably be perfectly smooth. But anyway, I guess when I do this, I'm gonna put on a pretty generous amount of heatsink compound. This stuff is brown, which I gotta say I've never seen before. Brown heatsink compound. It's usually white, but strangeness for me. But it says thermal grease. Well, I hope I ordered the right stuff. That's got to be the right stuff. Thermal grease. Brown thermal grease. We're going to see how this works and get it all down in the grooves. and let's just hope we don't blow it up. Hope we don't melt it. I'm not sure what kind of screwdriver you're supposed to do to screw this in, use to screw this in here, but it's I guess this screwdriver worked okay because it's got these little, because it's 1700 years old and it's got the rounded off little bits in the corners. I'm going to do another smoke test of sorts. This has all been hooked up before, but since I've mounted the amplifiers onto the heat sinks, you know, I had to plug all these wires back into the amplifier module board. So I don't think I've done anything wrong. I'm looking at the diagram over there. Plus side is this side, going to VCC plus. So, and they're reversed, right? So it's flipped over. So this one's going over here. That looks right. The negative side is this wire. And the other green and yellow one is here. The ground is coming to here. It's the double cord. It's double coming back out because there's two of them coming over to the protection circuit. That looks right. And that, pretty much nothing else I don't think could hurt anything. This is speaker wire looks correct. Inputs hooked up. Coming down here we've got, those are all still plugged in. I've disconnected the speaker wires because I've noticed in the past that if things are wonky, the protection circuitry here will try to kick on, and then if it's not happy, it'll kick off. So I've got these disconnected. And let's power it up. See if we get the lights that we used to get, which would be one on the power supply and then about 3 to 6 seconds later one on the protection circuit board. Yeah, happy times. All right, time to hook it up and play some music. So I'm trying to put on some royalty-free music. Yeah, it ain't great. Sounds really good. I cranked it up all the way, and this thing still gets pretty hot when it's all the way wide open, and at least this end will get hot, so hot you can barely hold your hand on it. And then this end over here will eventually, it all gets good and hot. I don't think it's lacking, I don't think it's a problem with it being mounted on this end so much as it might just be if there is a thermal problem, it could be because the heat sinks just aren't big enough, which is pretty crazy. But yeah, it works. We'll have to, the only time will tell if the thermal management is adequate. I've measured and I've marked and I've marked and I've measured, and I'm now ready to drill the holes into the heat sinks to mount the back panel. Only 6 more holes to tap. Yeah. Do not underestimate how difficult it can be to get all these holes in the right spot for whatever kind of amplifier design you decide to do. Set aside some time, measure twice. Mine's far from perfect, so just saying. Yeah, it's 2 days later, and my new tap has arrived from Amazon. Because when I was making my last video, or right after I made the last video, I broke a tap. And of course, you know, whenever you break a tap, you break it in the material, which means you can't use that hole that you had drilled that you wanted to tap out, because it's now got a chunk of tap in it. These taps are, this is a number 4. It's really small, so I gotta be more gentle with it. And when the tap's that small, they're easy to break. So I'll get back to it. Earlier I mentioned a special component that's going to be key in this build, were these little L brackets, and here they are installed. One side of that L bracket is, well, it just passes through, but the other side is threaded. So I'll be able to, I don't have the front ones on, but I'll be able to put L bracket on there and then just screw in from the other side. Here's a good example. See, I'll be able to drill holes in the panel. This will be the bottom or top panel, bottom panel, I guess. The bottom panel will go on here, and then you'll be able to screw right into the L bracket right there. And that's going to be key in making the top panel removable. The bottom panel too, but not so much, because the bottom panel will have things mounted to it, like the circuit boards. The top panel will be completely free, and I'll just be able to unscrew these and take it off. It's about to get real. I've got power supply. I haven't got it screwed down all the way. I've got the speaker protection mounted. Had to come up with some kind of way to rig, and I'm going to glue this wood to the bottom panel to mount the DSP. Now the front panel is really just kind of a thought right now. I got some stuff laid out here. I got a hole cut out and I want to mount the ESP32 right on there like that, and then, you know, mount it on there. Mount it on there, and then wire up all the rotary encoders and switches and buttons. I don't know how I'm going to mount this though. It doesn't come with. There's no mounting holes, no standoff, of course. That panel's all covered by screws, but I got the panel cut for the top. But it's been drilled out, and has it been drilled out? No, I gotta drill those holes. Okay, well, I gotta drill out the top panel. Everything's been cut to fit. The front panel here, mounts are there for it. The holes are marked. Now, I gotta drill holes in the top panel above the power supply, and I gotta make them holes nice and straight, and I don't know how to do that without getting that thing going, which I haven't gotten it going since I moved into this house, but I may have to spend some time working on it. That's probably the easiest and best way to get really accurate holes that have a good pattern to them drilled into this thing so that it looks really nice. I'm getting ready to drill out the faceplate. In the end, I probably want the faceplate to be made of aluminum, so this one may be sort of a prototype, but I don't know. I want it to look decent. When I'm doing this kind of thing, I have a hard time getting these holes in the right place, even on a drill press, which is kind of probably sad to say. So I like to put a board, a guide board, especially if I have several holes that are going to go in one line. I'll measure, this is 25 millimeters, right? 25 down. I'll set it up so that my drill comes down on 25 on one of these, and then I can just drill all 4 of them across, or however many it is. Don't underestimate how hard it is to get the holes in the right spot, and it's going to look funny if the holes on your front panel, your knobs don't exactly, they're not evenly spaced and stuff like that. So we'll see how this turns out. I need a 5-volt supply to run the DSP and the ESP32. Now, my original idea was this little power supply that I purchased. It's really cheap. It has a 12 volt and a 5 volt out. It runs off of AC. I mean, it works fine, but it only produces 100 milliamps on the 5 volt side, so it wasn't enough. It would power the ESP, but it wouldn't power the DSP. ESP, DSP. So I bought this power converter. This takes a DC in, and I'm going to hook it up to a 12 volt output that I have on the big power supply and have it produce the 5 volts for me. But right now I'm having to do a engineering change request because I'm going to mount it on these L brackets, so it'll be sitting in here like this. And now I need to drill holes in this bulkhead firewall. It ain't much of a firewall, it's made out of wood. You need to drill holes. I got a hole mark there, and I got a hole mark there. And I need to drill holes in there in Need to drill holes into an assembled product, which is like an engineering change request, right? After it's already been assembled, and the drill won't fit. Yeah. Wow, when I was younger and I had a steadier hand and better eyes, yeah, this stuff was much easier. But I think I've got it wired up. I'm getting ready to do some testing. And it's a momentous occasion. First time the amp's ever been powered up as a complete enclosed unit. So, yep, completely enclosed. This is too long. I shouldn't need it. I wanted to have a gap there. Nope. I'm about to hit the, oh, I'm going to hit the power button. Well, actually the power button on the front panel here is not actually wired up. For safety, I usually I'll do it last. It'll be like the very last thing I do. See if I can show the display while I'm powered up. And I heard the click. Turn the volume up. Put everything flat. Imaging on, loudness on, and then I'll go find some, I'm gonna go find some royalty-free music. Oh, this got some bass. Let's turn down on the phone quite a bit. I'll be experimenting with this amplifier. I'm afraid I popped the woofer. That woofer down there is popping. Unfortunate, I guess I'll have to replace it. I don't know if you can hear all this. I'm going to go through the ranges. See how much brighter it got? Treble's working. Mid-range. Bass. Ooh. Boom, boom. Oh, got a shadow. It's like a piece of art. Some piece of artwork right there. Ugh. Well, it is time to take this whole thing apart. Well, not all of it, but a lot of it. I got to take it apart because I want to put the new faceplate on. I got a faceplate made. Isn't that cool? Pretty cool, huh? I don't know if anybody's gonna like it but me, but there it is. It's cool. I got a faceplate made. I've also got a top plate. Hang on. Oh no, I'm burning your time, so let me grab this real quick. I got a top plate made. Got a bunch of holes drilled in it so that it can get air through it. Isn't that cool looking? Cool. Now there's lots of flaws, tear outs, crazy amounts of tear outs because I put it on them. I designed it so that the CNC machine would go through. I reversed it so that it would go through, and the machine would then, you know, drill into the wasteboard. Well, didn't work very good. Didn't work very good because I got tons of tear outs. I wouldn't have been better off to just drill it from the top side, which is what I did on this one. Drilled that from the top side, and it looks a lot better. So, lesson learned. Now where I'm at, you got to take this faceplate off, put the new one on. Then I got anything that's mounted to this bottom plate panel, I got to dismount, take the bottom panel off, drill holes in it like I have for the top panel. That pattern will be a little different, but similar. So drill holes in it and then put it back on. I also need to mount the DSP permanently. I'm going to rebuild this rat's nest back here. I've got PCBs. I'm going to put up whatever circuit I come up with. I'm going to put on a PCB. I'm also going to get a signal relay. I got some coming from the eBay. Got some signal relay coming so that I can not just this switch right here is crappy. It's not audio quality, so I think it's putting a lot of noise. I got some noise problems I still haven't figured out. As far as the wiring goes, I need to bring earth ground into play. Haven't done any of that yet. Need to earth ground these two heat sinks and some other parts of maybe the chassis back here. Anything that a metal that a finger touches really kind of needs to be earth grounded, like this switch and probably these buttons on the front. So I still got quite a bit to do, but you know, I've been listening to this amplifier for a long time. It's very powerful and it sounds really good. So I'm happy with it so far. I probably got about 300 bucks in it, which that's a lot, but it's a lot. It's a 200 watt amp, right? So like 200 watts per channel into 8 ohms. I can't even measure it, so I don't know how much. It's supposed to be 200 watts. I think this is probably a pretty good time to round out, round up, shut down, roll down. I can't think of the right wording. This section of the build, this section of the videos for the build. I've got videos that I've taken of the build. The build has progressed a little bit more than what I'm showing here, but it's a good time to, I think, make a break, because we kind of now have, we have an enclosure for the amplifier, and I've shown, you know, sort of how the ventilation is going to work. There are probably going to be heat related problems to solve, and maybe some noise related problems to solve. In direct mode, there's almost no noise floor, but when the DSP is in the signal path, there's a little bit of a hiss. Maybe there's some other things I got to figure out. The display on the ESP32 got damaged somehow. You can hear all about that in another video. But I think, like I said, I think this is a good spot to round this video off. You kind of now have the big picture, how it all goes together, and what mostly, for the most part, what all the components are. Now, you know, obviously we can't put really any kind of a value on the amount of time that it took to, you know, create, I guess you would say mentally create the designs, all the time that went into programming the DSP, learning how to control the DSP from the ESP32, programming the ESP32, which I'm a software developer by trade, so that stuff's not really that hard for me, but you know, it might be for others. And then I'm sure others would probably have a better cabinet design, but it works and it sounds pretty good. Now, if this amplifier plays to its specification, which the specifications are pretty, I think, put it in a pretty elite class. I mean, we're talking about, you know, it's supposed to be 250 watts into 8 ohms per channel, 500 watts. And at 100 watts, it's supposed to only have 0.01% total harmonic distortion. That's hard. That's going to be hard to beat. Trying to put some kind of price on it, I said earlier, you know, I think I've got about 300 bucks in it. The heat sinks were not cheap. I'll try to put up here what they cost. I'll look it up and pull up the order. What else is a relatively expensive part? So yeah, so I've got money, right, tied into lots of little things, like you know, like the connectors that go on the back panel. You know, things like that are hard to buy in a small number. See, I needed three RCA jacks for the back panel, right? And I can't buy 3. I mean, I could buy 3, but I'd end up paying $15 for 3, right? Or I can get 12 for $15. So you end up buying things. Another good example would be heat shrink tubing, or the little connectors that you have to crimp onto the end of your wires, the crimping tool. All of that stuff adds up. So the first build is going to be a lot more expensive than even the parts that you use in the build. You're going to have all this stuff left over. I ended up having to buy a new soldering iron because the one I'd had since I was in high school quit on me. But it didn't quit. It was running way too hot. And it was also, I mean, I thought it was running tips, but turns out tips are just cheap these days. They don't work for long. Anyway, the value proposition, I think, is really there. To build something like this, the price of something like this on the retail market, you know, a basic amplifier with 100 watts per channel at 0.01% harmonic distortion, 2-channel, probably not any kind of a DSP in it, would probably, you know, it's $500 if it's got any kind of quality or warranty or anything to it. And amplifiers in that sort of, if it really does sound as good as the specs say, and if it sounds as good as it seems to sound to me. Now, I'm not a pro listener. I've had, you know, I've got an old Yamaha Natural Sound, like I think it's like 50 watts per channel. I've got a Pioneer Elite home theater receiver that's like maybe 85 watts per channel. I've got a Denon. I had a Class D amplifier. You know, none of those none of the other amplifiers that I've mentioned have the kind of power that this amplifier has. And you can feel it, hear it in the dynamics of the music. It's just willing, I guess I would say, to make the music what it's meant to be. I don't know any other way to explain the fact that it has a lot of power, and it's just as clear and detailed as any other amplifier I've ever had or owned. Now, I can't say that I'm qualified to sit here and tell you that this is one of those amazing amplifiers that could probably compete with a $5,000 amp. There's amplifiers out there that are ridiculous, right? Do they sound that much better? I've never heard one. Maybe. I don't know. You know, if this thing's worth 300 bucks and it sounds as good as an amplifier that's $1,000, I would be happy, right? If it sounds as good as one that's 5,000, 10,000, it's possible. We'd have to A/B them, put them side by side and see. It's the only way to know, right? So, and I'm probably never going to be able to do that. But maybe someday, you know, maybe I can get it into the hands of somebody that's got some really elite stuff, and we can test it out. But it's probably not going to be very soon. Anyway, this is a good place to round this video out, and the next one about this amplifier will probably be all about engineering change requests, because it's kind of built, right? And anything that I do to it is going to either require taking it apart or making the change with all the other pieces in place. So, might not be that fun, but all right, well, I hope there's a few things in here that might, I mean, I want you to be a DIYer. I want you to build amplifiers and, you know, send me comments that say things like, Rob, appreciate the tip. When I built my amplifier, I did it this way. Or, appreciate the tip. You totally screwed it up. You should have done this. That's what I'd like to see. That's what I'd like to hear from you folks out there in YouTube land. So get in the comments and let me know what your DIY amplifier building experiences are like. Alright, now let's see if we can get it right this time. I don't know what the heck was going on last time, but let's see. The foot bone connects to the shin bone. The shin bone connects to the knee bone. The knee bone connects to the hip bone, right? And then the hip bone connects to the backbone?